Welcome back everybody, my name is Dustin. In the last video we actually started getting into scripting a little bit. We didn't really do much, all we did was get it running so it's actually saying that we're updating in Lua and we're rendering in Lua. In this video we're actually going to get away from scripting, we'll come back to that later, and we're going to move back to rendering. Currently we're just making everything inside of our application.cpp file here, and we're creating all of our buffers and all this stuff inside of here. And we don't want to be doing that, it's not a very efficient way to do things, and we're not making good use of our new ECS system that we put in. So in this video we're going to actually try to make a simple batch renderer. I could make a sprite class and draw all the sprites using a draw command for each sprite. However, it's more efficient to add as many sprites as you can into one batch and make one draw call per batch. We may not finish everything in this video. It might be split up into multiple because we have a lot to go over. First thing we're going to do is open up our Solution Explorer and go to rendering. We're going to go to core here and we're going to add new, and we're going to call this our batch render.h. Okay, and we're going to need a few things here. We're going to need our vertex, and we're going to need a vector, and we're also going to need memory. And then we'll make our namespace, and this one is Scion rendering. Okay, and it's class batch renderer. Okay, so we'll have some private and we'll have public. Cool. So we're making a batch renderer. So the first thing we need to understand and what to define is what a batch is. So if we quickly take a look at GL draw elements, this will help us see what we actually need inside of our batch. So we have our GL enum mode, and that's just going to be our GL triangles. Then we have GL size I count. The count is actually going to be the number of indices that we have in each batch. Then our enum type, that's GL unsigned int, and then the const GL void star indices. Right here, it doesn't really make sense when you look at it this way, but this here explains it really well. Indices specifies an offset of the first index in the array in the data store of the buffer currently bound to GL element array buffer target. So it's basically an offset. It says indices, but we're going to have it an offset. So what do we need? So we need num indices, we need an offset. Then we also are going to need, if we take a look at GL bind texture unit, because we're going to be using that, we don't really care about the unit right here, but we do care about the texture. And the texture is just going to be our texture ID. So that's what we need there. So we're going to need for our batch, we're going to need the number of indices, we're going to need the offset, and then we're also going to need the texture ID. Let's create that batch. The batch will be struct, and we'll just call it batch. That has GL, everything can be GL uint, num indices, and it'll be 0. And then we'll have the offset. We can have that to be 0 for now. Then we can have texture ID 0. Cool. And since we don't need the batch outside of the batch renderer, our batch can be private, a private struct. We'll keep everything inside nice and neat. So now that we have defined what a batch is, we can now define what a sprite is. In 2D games, sprites are usually quads or squares with a layer and a texture. Each quad has 4 vertices, your top left, top right, bottom left, bottom right. So each quad is going to have our 4 vertices and our 6 indices. Now our indices are going to be done inside when we actually are creating or generating our batches. For our sprite, we can basically just call it struct sprite, and whoops, inside of that we can go vertex, and it's top left, bottom left, top right, bottom right. Then we're also going to need a layer, because it's, if you remember 2D, it's usually layers. So it's kind of like a picture book. Everything that's on top, you lay things on top, or a canvas. So you do your base first, then you do your trees, and then your player and things of that nature. So it's a layer. Then we're also going to need our GL uint, and that's our texture ID. Cool. So those are the 2 structs that we need to get started. Now we're also going to need I like to separate things. So these are our structs and that we created inside, and then this is going to be our class members here. Now, if we go back to our application.cpp up here, we're going to want to take this stuff out. VAO, VBO, IBO. We want these now to come out of the application and into the batch renderer. So that's what we're going to do. So we're going to go GL uint MVAO, MVBO, and MIBO. What are these again? This is your vertex array, then your vertex buffer array, and then this is your index buffer array. So now we're also going to want to have a vector of our sprites. So we're going to go std vector std shared pointer of sprite, and that's going to be our m sprites. And then we're also going to need a vector of batches. This will also be a shared pointer of batches. It's not batches, it's a batch, and that's m batches. Okay, so we have our batches. All right, and then one more private here. This is going to be our functions. So we can even say that too. We can say functions, class members, and then we can just say member structs, I think. Member structs. We'll say that. All right, so we're going to have two functions inside of here. One is going to be void initialize, and then the other one is going to be void generate batches. The initialize function will initialize our VAO, VBO, and all that stuff that we're doing in application here. All this stuff to be at the beginning. This will all be done inside of our initialize. And generate batches will actually generate the batches based on our sprites that we're sending in. We're also going to have here our batch renderer, constructor, and destructor. Then we're going to have a void begin, void end, void render, and we're also going to have a void add sprite. Now these ones don't take anything, but the add sprite does. The add sprite is going to take a const glm vec4 reference, and that's going to be our sprite rect. Then we're going to have a const glm vec4. That's going to be our uv rect. Then we're going to have our gl uint texture id. And then we're going to have our int layer, and that'll default to 0. Then we're going to be sending in our glm mat4 model. Okay. So the model is what we're going to be using for any translation or scaling and things that need to happen like that, or rotation, any transformations of our vertices. And that'll just default as 1.f. Now what that is basically your identity matrix. Let's put this down on the next line. And the last thing will be color. So we'll go const color reference color is equal to color, and we'll just default to white. Okay, so now that we have all those, we're ready to create them. Create definitions. This will create them in our new batch renderer.cpp file. So let's go to that. Batch renderer.cpp, and just for and we'll remove this stuff. You can keep it that way if you like it, but I like it this way better. So we'll remove that. Okay. 2 more. All right. Okay, so the first thing we can do here is initialize our VAO. That can be 0. We'll set these all to 0. VBO 0 and IBO 0. And down here we'll have our sprites and our batches. Don't know why that's doing that. What did I do wrong here? Oh, look at me, so silly. Okay, and batches. Oh, I'm messing up everywhere today. So anyway, M, IBO. All right. And then I probably spelled that wrong too. M batch is. Sorry guys. Okay. Okay, and inside of this, we will call our initialize. Okay, so let's do the initialization. So before we initialize, we can create some very handy const expr expressions up here. We can go const expr size t. And this is going to be the num sprite vertices. As we said before, that's going to be 4. And then we're going to have num sprite indices. That's 6. We have 6 indices. Then we're going to have num max sprites. We can put this to whatever you want. Right now we'll start with, I don't know, 10,000. Sure. And then let's have max indices is equal to max sprites times num sprite indices. Let's change this to max sprites. And max vertices is equal to max sprites times num sprite vertices. All right, that should get us started. So basically we want to go back here and grab all that beautiful stuff from our application class. We can come here and we can probably take all this stuff. Take all this, X, and bring it over here and plug it in here. Okay, let's clean this up real fast. All right, so now that's cleaned up a little bit. We got a little error here. That's because of this here, our buffer data. So what we're doing here is we're binding our buffer, VBO, and now we want to do a buffer data. And for this, we're just going to go max vertices times size of vertex. Then we're going to have null pointer and GL dynamic draw. Cool. And I believe all those are good. All right. And we can, now we have some stuff we have to do in here. So let's quickly just write, actually this is good. This is our color. This is our UVs. And this is our position. Cool. So now that we're doing a batch, we actually want to generate the correct number of indices for the max number of sprites. So what we're going to want to do here is create a GL uint, and that's going to be our offset. And it will start at 0. Then we're also going to have a GL uint, and that's going to be our indices, and it's going to be the number of sprite indices And that's just going to be, if you remember from before, let's go back to application.cpp and see where our indices are. This is basically what it is here. We can actually copy this or even cut this, bring it over here and paste it in, get rid of this, change this to num sprite indices, and we can actually initialize it like this. So that's moved, that's clean. Okay. All right, we're not just rendering one sprite anymore, so we're gonna have more than 6 indices. However, they all need to follow the same pattern. So we need to create an array of indices. So we go auto indices array, and that's gonna be std make unique. So we're gonna make a unique pointer of gl uint array, and this is gonna be the size of max indices. Okay, and if we highlight this, that is 60,000. So we want to go through that, and we basically need to offset after every 6 needs to have an offset of the 4 vertices. So we want to go through and loop through all these. So we go for size t I is equal to 0, I is less than max indices, then I plus equals num sprite indices. Okay, so we're going to loop through all these 60,000 indices, and we're going to, every time it comes around, we're going to be incrementing our I by 6. So here we're going to go loop in another loop, and it's going to be size t, and we're going to call this j, it's equal to 0. J is less than num sprite indices, and then we're going to go j plus plus. So what we're doing here is we want to loop through, and for each of the indices array at I plus j is equal to indices at j plus the offset. Does that make sense? This goes up to 6 because the number of sprite indices is 6, and we have 6 here. So at 0, it's going to be 0, 1, 2, 3, 4, 5. Because it goes from 0 to 5, so it's going to be less than 6. So plus our offset. And what I said before is our offset is going to be based off the number of sprite vertices. So every time it goes around, it's offset plus equals num sprite vertices. And that should set it up for us. So that sets up all of our arrays and the correct offsets and the correct positions of those offsets. So now we can generate the index buffer. So we go gl gen buffers 1 IBO. Then we want to bind gl bind buffer. And then this one is a gl element array buffer, and it's the IBO. And we want to buffer the data, gl buffer data, gl element array buffer, and that's the size of gl uint times max indices, and then we sending our indice array, indices array dot get. We're sending it in as a pointer, and this is a GL dynamic draw. Okay, so for the IBO, we only have to do this one time. The things that are going to be changing is our VBO, and that'll be changing in our generate batches function. And then we can set, so then we can say generate the index buffer, not biffer, buffer. Cool. Now it's time to go over how we generate batches. First thing we're going to want to do is create a vector that will hold all the vertices of the sprites that we have. So let's do that right now. So we go std vector, vertex, vertices. And to help performance, we want to go vertices dot resize based on the number of sprites we have times the number of sprite vertices. This will help increase performance doing our batch because we can now access the vertices using an index rather than using pushback. So we're going to want to loop through all the sprites, and for all the sprites that have similar texture ID, we're going to want to just add the number of indices, which would be 6 in our case, to the current batch. If the texture changes, we want to create a new batch. Before we do that, we're going to need some local variables, and that's going to be int current vertex, and that'll start at 0. And we're going to have current sprite, that'll also start at 0. Current vertex will be the index of the current vertex data that we will be assigning in the vertices vector. And the current sprite will be the sprite that we're currently looking at in our sprites vector. Okay. Then we're also going to want to have an offset and a previous texture ID. So we go gl uint, that's our offset. That'll start at 0. And then our prev texture ID, that'll also start at 0. The batch offset is used inside the render function, so it knows where to start reading our data. That's what we were talking about before. That's our offset that we're sending in. So it knows where to start looking at those indices. So we have those now. Okay, so now that we have our local variables, we can loop through all of our sprites and create the batches that we need. And that's for const auto reference sprite in msprites. We're going to go if the current sprite is 0, we want to create a new batch. So if current sprite is equal to 0, we want to go m batches dot in place back std make shared, and we want to make a batch. And here we go like this, and we're going to say batch dot num indices is equal to num sprite indices dot offset is equal to offset, and dot texture ID is equal to sprite texture ID. Cool, and we can bring this back up there. Okay, so if the current sprite is not 0, we also want to check to see if the current sprite texture ID is not equal to the previous texture ID. We're going to want to create a new batch because we're going to be trying to batch everything based on that current texture. So we only have to bind the one texture. So we basically want to do the same thing. We can just copy that, paste it there. And else, so if the current sprite is not 0 and the previous texture is the same, we're just going to add to the number of indices that the back batch has. Dot back num indices plus equals num sprite indices. Cool. Let's bring this down a bit. Okay, so now that we have the batch creation set up, we now want to set the values of our current sprite inside the vertices vector. If you remember, each sprite has a top left, top right, bottom left, and bottom right vertex. So we need to set the data as follows. So we can go vertices at current vertex. Let's go fix that. Vertex, current vertex plus plus is equal to sprite top left. So what this does here is this will increment the value of the current vertex in a postfix manner, meaning that after the operation is done, the current vertex will be incremented by 1. So at this one, it'll be 0, but at the next one, it's starting at 1. And then this is going to be top right. And then we do it again, we go bottom right and bottom left. All right. Okay. So the last things we need to do here. So now we want to set the previous texture ID to the current texture ID. And then we also want to update our offset by the number of sprite indices. And then we also want to increment our current sprite. So we go prev texture ID is equal to sprite texture ID. Then we go offset plus equals the num sprite indices. And then we go current sprite plus plus. Awesome. So that will handle taking care of our batches for us, setting the vertices that we need them to be. And we need this vertice data down here. So now we want to actually set up the new data with OpenGL. So the first thing we're going to do is bind our VBO. So GL bind buffer. And that's going to be GL array buffer MVBO. Cool. So if we make a call again to GL buffer data on this VBO, it will orphan the current buffer to make room for the new data that we're going to be sending in. The old data will remain in the GPU until all OpenGL commands and processes are done with that data have been completed. Then it should release it on its own, but you never know. GL buffer data, and this is our GL array buffer. And then we send in our vertices dot size times size of vertex, null pointer for the data, and GL dynamic draw. Now that the old data has been orphaned, we're going to want to upload the data, the new data, with GL buffer sub data. So GL buffer sub data, and that's GL array buffer. And then we send in our offset, it's going to be 0, and it's vertices dot size, that's our size that we're sending in, and then the data that we're sending in. Oh, vertices dot size, sorry, times the size of the vertex, and then the data that we're sending in, and that's just vertices dot data. Awesome. Now that we're done uploading the data, we can actually bind the buffer to 0. So we can go GL bind buffer, GL array buffer, and set that to 0. Okay, we're almost done. So now we can quickly go here. If any of our vertex array, vertex buffer object, or index buffer object is not equal to 0, we're going to want to delete them. So MVAO GL delete vertex arrays 1 MVAO. We can copy these VBO IBO GL delete buffers. IBO VBO. That's in our destructor. And then for the begin, all we're going to want to do here is clear our batches and our sprites. So we just go sprites dot clear and batches dot clear. So that means every time that we loop around, we're using a fresh batch. And in the end, so this is our start batching, our end batching. First thing we want to do is check to see if there's any sprites. If there are no sprites, there's no point to even do any generation. So if there's no sprite, sprites dot empty, we're just going to return because there's nothing to even generate here. So if we get here, we're going to want to sort the sprites based on their layer. So we can go std sort, not sortable. And in order to use std sort, we're going to need algorithm. So go up here, include algorithm. And so here we want to sort the sprites. Sort the sprites by their layer. So what this does is it takes in a vector m sprites begin m sprites.end, and then a function, a sorting function. So we can send in a lambda function here, and then it can just be const auto reference a, const auto reference b. Sorry, this needs a comma here. Cool. And what we're going to do is go return is A's layer less than B's layer. And it'll sort it accordingly. So here, after we've done the sorting, after we've checked to see if we actually have sprites, we can now generate the batches. So we just go generate batches. Cool. All right, the render function is actually really easy. The first thing I like to do is check to see if we have any batches. If we don't have any batches, there's no need to even be here. So we just go if mBatches.empty. We're just going to return. And then if we made it here, we do have some batches to render. We want to bind our vertex array. So GL bind vertex array MVAO. Cool. Now that we have our vertex array bound, we're going to want to loop through all the batches and render them accordingly. So we go for const auto reference batch in our batches. Now what are we going to do? So the first thing we're going to want to do here is bind the texture, and with that we can use GL bind texture unit. So GL bind texture unit. This takes in a unit that we'll want to set active and the actual OpenGL texture ID. We'll just be binding this to unit 0 because we most likely won't be using multiple texture units. However, this can be adjusted in the future if you need to. So we'll just say 0 and we'll say batch texture ID. And now we can do our GL draw elements. Draw elements. Cool. And if you remember from earlier, it's GL triangles. Now we want to get our batch, and that's our num indices. Then we want to say GL unsigned int. And then the last one is our offset. And for our offset, we're going to want to go void pointer size of GL uint batch offset. So void pointer, the size of GL uint times our batch offset. Cool. And then if we made it here, we can just unbind the vertex array. GL bind vertex array to 0. All right. One more function. I believe we're almost done. That's our batch render. Okay, so one more is just to add sprite. Our sprite vector is shared pointers of sprites. So we're going to want to add a new sprite based on the data that we have sent in. So we go auto new sprite is equal to std make shared sprite and we're going to want to go sprite. First thing that we do is the top left, and that's equal to vertex. Bring that over. And what did we declare first in our vertex? Let's go here. So it's position, UVs, color. So let's go back. So our position, so dot position of our top left vertex is going to be equal to our model matrix multiplied by GLM vec4 sprite rect dot x sprite rect dot y 0.f, 1.f. So in this case, our top of the sprite rect, or top left, is our 0, 0 point. And then our UVs is going to equal GLM vec2 UV rect dot x UV rect dot y. Then our color is just going to be the color that's sent in. Okay, there's our top left. Copy that down one. I think it's top right. Let's go back over here. See how we did it. So top left, top right, bottom right. Okay. Bottom left. Top right. And then bottom right. Now, when you copy and paste like this, it can be problematic. Bottom right. But we'll make sure to take our time here and get it set up properly. So the position for the bottom left is actually going to be sprite X, sprite Y. See, we made a mistake already. So the top left is actually going to be sprite X, sprite Y plus sprite rect dot W. And this one's going to be UV rect dot W. That's a plus, sorry. And this is the bottom left. That's what we want it to be. Bottom left is our 0, 0 in this case. And then our top right is going to be sprite X plus sprite rect dot Z. This one is going to be plus sprite rect dot W. So this is your top right corner, so 1 and 1. So down our bottom left is going to be our 0, 0. Sorry, I said that incorrectly. Bottom left is 0, 0. Top right is 1, 1. So the same here. We're going to go v rect dot z, and this is a plus. Copy this. W. So this would be our bottom right, and bottom right is going to be a 0 and a 1. 0 and a 1. 0 down, 1 across. Plus sprite rect dot Z plus UV rect dot Z. All right. Okay, so then we have two more things. We have our layer, and that's going to be equal to layer. And then we're also going to have our texture ID, and that's the texture ID. Okay, I don't know why that covered it up. And that's the generation of our sprite right there. So now that we have our sprite, we can actually put it into our sprite vector. Dot msprites dot pushback std move. We want to move it into there, and that's the new sprite. Awesome. So that's basically everything for this video. And in the next video, we can't actually do anything with this right now. Well, you can try. But in the next video, we're actually going to make a render system that will use the batch renderer. If you want, you can try it out yourself. So just go to your core, and in the core, go to your systems and create a new system. So if you go back into your scripting system, you see how we did this. We got our view from the registry, and we got a script component. And then we loop through that and do what we need with it. So what you're going to need to do here is get your view, and it's going to have a transform component, and it's also going to have your sprite component. And you're going to have to go through and try to render in there. So give it a shot, see what you can do, and we'll go over that in the next video. Take it easy.